Okay, so in this final problem type 4, we're going to be doing the same thing we're doing in other problems, and that is they give us some information, and then we want to find some other trig functions. So in this case, we have let theta be an angle such that the cotangent of theta is equal to 7/4, and that the sine of theta is greater than 0, and then they want us to find some stuff. So the first thing I'm going to do is I'm going to draw the angle. But unlike other problems in this case, just from the cotangent of theta being 7/4, I don't know exactly where to put it. So the cotangent is positive. So if we remember our mnemonic, right, all students take calculus. So the places, if I'm dealing with the cotangent being positive, one of the places I could be would be in this quadrant because all the trig functions are positive there. And the other place I could be is down here in quadrant 3 because in quadrant 3, the tangent is positive, which also means the cotangent is positive. So I'm still not sure where it needs to go. So I need to use this other piece of information about the sine of theta also being positive. So if we think about the places where the sine of theta is positive, the sine of theta is positive in the first quadrant because everything is positive there. And then it's also positive in the second quadrant. So now we know that our angle, theta, is lying in this first quadrant here because this is the place where both the cotangent is positive and the sine is positive. So I have some angle sitting in here, theta. And I'm going to drop down, make my reference triangle. So it tells me the cotangent is 7/4. So remember, cotangent is adjacent over opposite. So the opposite would be 4. The adjacent would be 7. They're both positive because this is going up and the y-axis up here is positive. This is to the right and the x-axis to the right is positive. So that's good. And then we need to use the Pythagorean theorem to find c squared, right? So 7 squared plus 4 squared is equal to c squared. So 49 plus 16 equals c squared. So we get 65 is equal to c squared, or c is equal to plus or minus the square root of 65. Remember, c is the hypotenuse, so we always make the hypotenuse positive, so it's positive square root of 65. And so now I just have to figure out what is the cosecant of theta and what is the cosine of theta. So remember, cosecant is adjacent, so square root of 65. Oh, or not adjacent, I'm sorry, hypotenuse. So square root of 65 over the adjacent, so over 7. And, oh, I totally did that. No. Let's write it out since I said it totally incorrectly and wrote it. So cosecant, right, is the hypotenuse over the opposite, right? So the hypotenuse here is square root of 65. The opposite is 4. So it should be the square root of 65 over 4. It should be the answer there for the cosecant. Sorry about that. Cosine is adjacent over hypotenuse. So the adjacent is 7 and the hypotenuse is the square root of 65. So it's not too bad, but you have to do a little bit of work to figure out what quadrant it's in. So let's try another one of these. So my second example here, let theta be an angle such that the secant of theta is negative 13/5 and the cotangent of theta is greater than 0. Find the tangent and the cosecant. So the first thing that we're going to do is I'm going to draw this xy axis. Again, here we're looking for the secant being negative. So remember, secant is paired with cosine. So we're looking for where is the cosine negative. So everything's positive there, so not there. Sine is the only thing positive. So sine and cosecant are the only things that are positive here. So the secant would be negative in this quadrant. So all students take, so that means tangent and cotangent are the things that are positive there. So the secant would be negative in this quadrant. And then calculus is cosine and secant being positive. So it's just quadrants 2 and 3 from the secant part. We're also looking for the cotangent to be greater than 0. So the cotangent's greater than 0 in quadrant 1, because everything's positive in quadrant 1. Not in quadrant 2, because that deals with the sine stuff. Quadrant 3, the things that are positive are tangent and then cotangent. So that's the other quadrant where the cotangent is positive. And so now I found that quadrant where both things are positive. And so that's where my angle is going to lie. So it's going to be down here. So we're going to draw that reference triangle. And secant, right, is hypotenuse over adjacent. So in this case, that's going to be the hypotenuse, so 13, and the adjacent is 5. And then I have to check to make sure my signs are correct. So here, we're on that negative side, so I need a negative sign. And then 13 is the hypotenuse, so that should be positive, and it is. And then this works out well because I needed a negative because I had the negative there. So now I just need to find that missing side. So negative 5 squared plus b squared equals 13 squared. So 25 plus b squared is equal to 169. So b squared is going to be equal to 144. So b is going to be equal to plus or minus the square root of 144, or plus or minus 12. So I know over here we're going to have a 12, but because it goes down, all right, it's below the x-axis, it should be that negative 12. And now that I have all the pieces of my triangle, I can figure out what the tangent of theta is. So tangent is the opposite, negative 12, over the adjacent, negative 5. So this would be 12 over 5. And then the other one we're looking for is the cosecant of theta. And so the cosecant of theta is going to be the hypotenuse, 13, over the opposite side, so over that negative 12. So again, I could rewrite this if I wanted it as negative 13 over 12.